The JSON data type. We have creating JSON values, we have normalization, merging, and auto wrapping of JSON values, we have searching and modifying JSON values, JSON path syntax, comparison and ordering of JSON values, converting between JSON and non-JSON values, and finally aggregation of JSON values. MySQL supports a native JSON data type defined by the RFC 7159 that enables efficient access to data in JSON JavaScript object notation documents. The JSON data type provides these advantages over storing JSON format string in a string column. Automatic validation of JSON documents stored in JSON columns. Invalid documents produce an error. Optimized storage format. JSON documents stored in JSON columns are converted to an internal format that permits quick read access to document elements when the server later must read a JSON value stored in this binary format. The value need not be parsed from a text representation. The binary format is structured to enable the server to look up sub-objects or nested values directly by key or array index without reading all values before or after them in the document. MySQL 8.0 also supports the JSON merge patch format defined in the RFC 7396 using the JSON merge patch function. See the description of this function as well as the normalization, merging, and auto wrapping of JSON values for examples and further information, so you can check out this link. We have a note. This discussion uses JSON and monotype to indicate specifically the JSON data type and JSON and regular font to indicate JSON data in general. The space required to store a JSON document is roughly the same as for the long blob or the long text. You can check out the section 11.7 data type storage requirements. For more information, it is important to keep in mind that the size of any JSON document stored in a JSON column is limited to the value of the max _allow _packet system variable. When the server is manipulating a JSON value internally in memory, it can be larger than this. The limit applies when the server stores it. You can obtain the amount of space required to store a JSON document using the JSON _storage size function. Note that for a JSON column, the storage size and thus the value returned by this function is that used by the column prior to any partial updates that may have been performed on it. You can check out or see the discussion of the JSON partial update optimization later in the section. Prior to MySQL 8.0.13, a JSON column cannot have a non-null default value. Along with the JSON data type, a set of SQL functions is available to enable operations on JSON values such as creation, manipulation, and searching. The following discussion shows examples of these operations. For detail about individual functions, you can check out the section 12.17. JSON functions. A set of spatial functions for operating on GeoJSON values is also available. You can check out the sections 12.16.11 special GeoJSON functions. JSON columns like columns of other binary types are not indexed directly. Instead, you can create an index on a generated column that extracts a scalar value from the JSON column. See indexing a generated column prior to JSON column index for a detailed example. The MySQL optimizer also looks for compatible indexes on virtual columns that match JSON expressions. In MySQL 8.0.17 and later, the database storage engine supports multi-value indexes on JSON arrays. You can check out the multi-value indexes. So this is the link. MySQL NDB Cluster 8.0 supports JSON columns and MySQL JSON functions, including creation of an index on a column generated from a JSON column. As a workaround for being unable to index a JSON column, a maximum of 3 JSON columns per NDB table is supported. Partial updates of JSON values. In MySQL 8.0, the optimizer can perform a partial in-place update of a JSON column instead of removing the old document and writing the new document in its entirety to the column. This optimization can be performed for an update that meets the following conditions. The column being updated was declared as JSON. The update statement uses any of the three functions, JSON underscore set, JSON underscore replace, and JSON underscore remove to update the column. A direct assignment of the column value. For example, we have the update, my update set, and then jcall equal sign, and then inside we open single quotes, we open curly braces, and we're gonna have inside double quotes the letter underscore letter A colon, the value is gonna be 10. We're gonna separate by a comma. We're gonna have this key value pair per se, where inside the double quotes we have the lowercase letter b colon, and the value would be 25. We close the curly braces, we close the single quotes, and here we have we close the parentheses. Cannot be performed as a partial update. Updates of multiple JSON columns and a single update statement can be optimized in this fashion. MySQL can perform partial updates of only those columns whose values are updated using the three functions just listed. The input column and the target column must be the same column. A statement such as update my table set jcall1 is equal to the JSON underscore set, and inside of the parentheses we have the jcall2 comma separated, and then single quotes $sign that a comma, and then the number 100 cannot be performed as a partial update. The update can use nested calls to any of the functions listed in the previous item, in any combination as long as the input and target columns are the same. All changes replace existing array or object values with new ones, and do not add any new elements to the parent object or array. The value being replaced must be at least as large as the replacement value. In other words, the new value cannot be any larger than the old one. A possible exception to this requirement occurs when a previous partial update has left sufficient space for the larger value. You can use the function JSON underscore storage underscore free. See how much space has been freed by any partial updates of a JSON column. Such partial updates can be written by to the binary log using a compact format that saves space. This can be enabled by setting the being log underscore row underscore value underscore option system variable to the partial underscore JSON. It is important to distinguish the partial update of a JSON column value stored in a table from writing the partial update of a row to the binary log. It is possible for the complete update of a JSON column to be recorded in the binary log as a partial update. This can happen when neither or both of the last two conditions from the previous list is not met by the other conditions are satisfied. See also the description of being log row value options. The next few sections provide basic information regarding the creation and manipulation of JSON values, and we're going to see some examples. Creating JSON values. A JSON array contains a list of values separated by commas and enclosed within the brackets. So the brackets characters, and here we open brackets and we have 1, 2, 3, 4, 5 elements here separated by commas. So the first one is inside double quotes, and the letters are ABC lowercase letters. Then we have the number 10, then we have null, then we have boolean true and false. A JSON object contains a set of key value pairs separated by commas and enclosed within curly braces characters. So inside these curly braces, inside of the curly braces we have these key value pairs. So we have the key and we have the value. So inside of the double quotes we have the K1, that would be the key, and then inside of this double quotes we will have this value. And in the second example we have the key is gonna be K2 inside of the double quotes, but the value is just gonna be the number 10. As the examples illustrate, JSON arrays and objects can contain scalar values that are strings or numbers, the JSON null literal or the JSON boolean true or false literals. Keys in JSON objects must be strings. Temporal datetime or daytime scalar values are also permitted. So here in these brackets we have 1, 2, 3 elements, and inside of the double quotes we have these strings. So we have these numbers here. Nesting is permitted within JSON array elements and JSON object key values. So we have these brackets, we have the number 99 comma, then we have curly braces. Inside of the curly braces we have the key value pair, so we have the ID, that would be the key, and then HK500 would be the value, codes would be the key, and and 75.99 would be the value. The second element would be, again, we open brackets and we have two strings, hot and cold. So outside of that, we have the next example, and we have curly braces, and we have a key value pair, k1 the key, and the string value the value. And then we will have the second element with a key value pair, k2 is the key, and then the value would be this array with 10 and 20. You can also obtain JSON values from a number of functions supplied by MySQL for this purpose, so you can check out the section 12.17.2 functions that create JSON values, as well as by casting values of other types of the JSON type using the cast value as JSON. See converting between JSON and non-JSON values. The next several paragraphs describe how MySQL handles JSON values provided as an input. In MySQL, JSON values are permitted are written as strings. MySQL parses any string used in a context that requires a JSON value and produces an error if it is not valid as JSON. These contexts include inserting a value into a column that has the JSON data type and passing an argument to a function that expects a JSON value, usually shown as JSON underscore document or JSON underscore value in the documentation for the MySQL JSON functions, as the following examples demonstrate. Attempting to insert a value into a JSON column succeeds if the value is a valid JSON value, but fails if it is not. So let's check it out. I already logged in from the previous video with my credentials, and so let's create this one. So I am already in the database that I'm using. Okay, show databases. These are my databases. I'm using the common query databases, and this is my table. So we're gonna create a new table. It's gonna be create table, and it's gonna be T. I already have T1, so let's just name it T2, lowercase letters, and we're gonna open close parentheses, and we're gonna have the J document, and then it's gonna be JSON like this. Okay, so create table, we're gonna name it T2, and then press enter. Query, okay, 0 rows affected, that's fine. Now we're gonna insert some information, and you can just copy and paste if you want, but I'm gonna start typing it. So it's gonna be in uppercase letters. It's gonna be insert into, it's gonna be T2. We're gonna insert the values, and we're gonna open parentheses, and inside of this parentheses we are gonna have single quotes, and inside of the single quotes we're gonna have curly braces. So now we're gonna have key value pairs. Let me see, we're gonna have two elements separated by a comma. We're gonna have a key value pair separated by a column like this. Okay, and the next one is gonna be also separated by a comma, by colon, the key value pairs, and both are strings, so we need, this is gonna be double quotes. Okay, so the first key is gonna be just in lowercase letters, it's gonna be key 1, and this is gonna have the value is gonna be 1. So in the second is gonna be key 2, and the value is gonna be value 2 like this. And then we close the curly braces and single quotes and all the stuff. So let me see, we ended up with a semicolon, press it, and that's fine. We're gonna insert, so we're gonna insert into the table T2. We're gonna insert some values. Okay, so we're gonna open parentheses, and inside of the single quotes we're gonna have a bracket. It's gonna be 1, comma 2, and we separate by a comma, and we're just gonna leave it like that, and then we're gonna close it with a semicolon. And here we throw us an error. So as you can see here, it says error 3140, invalid JSON text, invalid value at position 7, and value for the column, so that's fine. Positions for add position uppercase letter N, and such error messages are zero based but should be considered rough indications of where the problem and a value actually occurs. The JSON underscore type function expects a JSON argument and attempts to parse it into a JSON value. It returns the values JSON type if it is valid and produces an error otherwise. So let's check it out, this example. So we're gonna select the JSON like this. It's gonna be JSON underscore and then it's gonna be type. We're gonna open parentheses and we are gonna have single quotes, and we're gonna open brackets and we're gonna separate it with a comma like this. So we're gonna have lowercase letter a, then lowercase letter b, and here we're gonna have at the number 1. So we have that, and okay, so we have this JSON underscore type and we are getting the array. Okay, so now we are gonna use the select. It's gonna be select and it's gonna be JSON underscore type. Okay, JSON underscore type, we open close parentheses and we're gonna have in the inside single quotes the string hello, inside double quotes and lowercase letters. So like that, press enter, and here we have a string, so it gives us a string. So now let's do the same thing, but instead of having it first inside single quotes and then double quotes, we're just gonna have the word hello inside single quotes. We press enter, invalid JSON text and argument 1 to function, invalid value. Okay, that's that. MySQL handles strings using JSON context using the UTF-8 MB4 character set and UTF-8 MB4 underscore bin collation. Strings and other character sets are converted to UTF-8 MB4 as necessary for strings, and the ASCII or UTF-8 MB3 character sets no conversion is needed because ASCII and UTF-8 MB3 are subsets of the UTF-8 MB4. So an alternative to writing JSON values using literal strings functions exist for composing JSON values from component elements. JSON underscore array takes a possibly empty list of values and returns a JSON array containing those values. So since this is a little bit a lengthy text, let's just copy and paste this. So we can just copy and paste that one, and we have the select JSON array. So we have select and then we have JSON underscore array, then we have this string a, we have the number 1, and then we have now. So let's press enter, and this is the result that we have. We have obviously a different date, since now is 2023. This is the year. We are August and we are the 2nd of August, and this is the time. Okay, so now we have the JSON underscore object takes a possibly empty list of key value pairs and returns a JSON object containing those pairs. So let's check out this example as well. Let's copy and paste it and let's move it here. Okay, so we have select and then we have JSON underscore object. We're gonna have these 3 elements. We're gonna have the key 1, this is a string, we have the number 1, key 2 a string, and then the string ABC, lowercase letters. And as you can see in these curly braces, they're giving us 2 key value pairs. Key 1 is the key and 1 is the value, key 2 is the key, and the string ABC is the value. Now we have the JSON underscore merge underscore preserve takes 2 or more JSON documents and returns the combined result. So let's check out this one as well. So let's grab this example, let's paste it, let's click enter, and now we have so we have the select JSON underscore merge underscore preserve, and we have two elements. This element, this is inside single quotes, and we open brackets, and inside of these brackets we have this string lowercase letter a and then 1. Then we have in this second element, we have inside single quotes, we have this we open curly braces and we have this key value pair with key and then the value as the key value pair. So the result that we have is the A, the string A, the number 1, and then the key value pair. For information about the merging rules, see normalizing, merging, and auto wrapping of JSON values. MySQL 8.0.3 and later also support JSON underscore merge patch, which has somewhat different behavior. See JSON merge patch compared with JSON merge underscore preserve for information about the difference between these two functions. JSON values can be assigned to user-defined variables. So let's check out this example as well, and this time we're gonna set it. So we are setting @j, and the equal sign is going to be JSON underscore object, and we're going to have these two elements, these two strings, key and value. Okay, so query okay, 0 rows affected. And let me see, now we're going to just pretty much select, we're just going to select the @j, and the result that we have is inside single and curly braces the key value pair. However, user-defined variables cannot be of JSON data type, so although @j and the preceding example looks like a JSON value and has the same character set and collation as a JSON value, it does not have the JSON data type. Instead, the result from JSON underscore object is converted to a string when assigned to the variable. Strings produced by converting JSON values have a character set of UTF-8 MB4 and a collation of UTF-8 MB4 underscore bin. So let's check out this example. So let's just grab it, and here, so we're gonna select and the char set, and the char set is gonna be @j, and then we're gonna have the collation also @j, and the char set, and we'll have two columns, the char set and it's taking @j, and then the collation that is also taking @j. So as you can see, we'll have the UTF-8 MB4 and then the UTF-8 MB4 underscore bin. So we're good, because UTF-8 MB4 underscore bin is a binary collation comparison of JSON values, is case sensitive. So let's check out this example. We're gonna select JSON underscore array, and inside of the parentheses we have this string x equal sign, we have the JSON underscore array, and also we have inside of the parentheses inside of the single quotes the uppercase letter x, and the result we're gonna have is a 0. Case sensitive also applies to the JSON null, true, and false literals, which always must be written in lowercase. So let's just copy and paste this example. So we are selecting JSON underscore valid, and inside of the parentheses let me see, it's JSON underscore valid. So here inside of the parentheses we pass in the string null, we separate it, and then we're gonna have again JSON underscore valid, and inside of the parentheses we're gonna have this time the string null with the uppercase letter n, and finally we're gonna have the JSON underscore valid. This time the string is gonna be uppercase letter n, letters null, uppercase letter null. So we press enter, and we are gonna have the first one is gonna be true or 1, and the second JSON underscore valid is gonna be 0, and the third one is also gonna be false. It's gonna be the JSON underscore valid, and since it's written in capital letters, it's gonna be false 0. Now we're gonna have in the select cast, so we can just go here, select cast, and we are selecting the string null, lowercase letters, as JSON, and we are getting null, so that's fine. And now we're gonna get an error, so let's check it out. Okay, so we're gonna select cast, and this time is gonna be the string uppercase letter null as JSON, and error 3141 invalid JSON text and argument 1. Okay, so we have that. Case sensitive of JSON literals differs from that of the SQL null, true, and false literals, which can be written in any letter case. So let's check it out. In this example we have the select s null, in the parentheses we have lowercase letter null, s null, we'll have the uppercase letter n null, s null with uppercase letters null, and this time we have true for the 3 examples. Sometimes it may be necessary or desirable to insert quote characters, double quotes or single quotes into a JSON document. Assume for this example that you want to insert some JSON objects containing a string representing sentences that state some facts about MySQL, each pair with an appropriate keyword into a table created using the SQL statement shown here. So let's check out this example. So we're gonna create table name facts sentence. Inside of the parentheses we're gonna have sentence JSON. We have that. Now among these keyword sentences pair is this one. So we have mascot. The MySQL mascot is a dolphin named Sakila. Okay, one way to insert this as a JSON object into the facts table is to use MySQL JSON_object function. In this case, you must escape each quote character using a backslash as shown here. So let's try it out. We're gonna insert into facts tables these values, and we're gonna copy it and paste it here. So we open and close parentheses, and we end up with a semicolon, and inside of the parentheses we are gonna have, and let me see, okay, we're gonna have the JSON_object, and then we're gonna open and close parentheses, and inside we're gonna have one in two elements. The first one is gonna be the string mascot, and the second one is gonna be the string our mascot is a dolphin name, space, and then it's going to be a backslash, and the name is going to be Sakila or whatever you pronounce it. So we press enter, and that's what we have. Now this does not work in the same way if you insert the values as JSON object literal, in which case you must use the double backslash escape sequence like this. So if you could do insert into facts value, you would do instead of writing JSON_object, you would just type in, you would start the single quotes and then curly braces, then it's going to be inside double quotes, and then the key value pair would be our mascot is a dolphin, and then double backslash, then the name and double quotes, and then backslash again. Using the double backslash keeps MySQL from performing escape sequence processing, and instead causes it to pass the string literal to the storage engine for processing. After inserting the JSON object in either of the ways just shown, you can see that the backslashes are present in the JSON column value by doing a simple select like this. So we can select sentence from facts. So let's check it out. Okay, so first of all, let's show tables like that. Okay, so now let's select sentence from facts. Okay, mascot, our mascot is a dolphin named Sakila, and that is from the, the shaft animals. Okay, from facts, from the table facts. Okay, that's fine. To look up this particular sentence, employee mascot as the key, you can use the column path operator as shown here. So let's move on. This leaves the backslashes intact along with the surrounding quote marks to display the desired value using mascot as the key, but without including the surrounding quote marks or any escapes. Use the inline path operator. So we would use that. You type in select sentence, and this time it will be an arrow, and then another greater than signs, double quotes, $sign that mascot from facts, and that will be the result that we will get. The previous example does not work as shown if the no_backslash_escape server SQL mode is enabled. If this mode is set, a single backslash instead of the double backslashes can be used to insert the JSON object literal, and the backslashes are preserved. If you use the JSON_object function when performing the insert and this mode is set, you must alternate single and double quote like this. So you have the single quotes here, and the name would be inside double quotes. So we have that, and you can check out the description of the JSON unquote function for more information about the effects of this mode on escape character and JSON values.